Hello viewers, welcome once again to Bash Maths Studio. Our lesson on Introduction to Differential Equation continues, and today's lesson is going to be on classifying differential equation in terms of the order, degree, and linearity. And when we are done with this lesson, the next one will now begin to finding the solutions to ordinary differential equations. So we start with the first equation here on the board, question 1 or example 1. We'll have this differential equation. So we have the first differential equation on the board. We have here e to exponent x divide dx minus 2x equals 3. So we want to see whether if this one is a linear. We want to see its order and then its degree. So first let's talk about the order. So order. The order of a differential equation is the highest derivative of the differential equation. The order of a differential equation is the highest derivative of the differential equation. So with this differential equation, the highest derivative there is dy dx. So it's just one derivative, only a first derivative of y with respect to x. So here we say that this differential equation is a first order or order 1. So it's first order. First order. First order. Then we talk about degree. So degree. What is the degree of this differential equation? The degree is also 1. The degree is 1. Or is of first degree. First degree or degree 1. Let's just short it as degree 1. So it's of degree 1. If we talk about degree of a differential equation, we mean the exponent or the power of the highest derivative of the differential equation. So here the highest derivative, as we talked about as an order, is the dy dx, and its exponent is what? 1. It's of power 1, and therefore we say that this one is of degree 1, is of first degree. Then we talk about the linearity. So linearity. So what is the linearity of this equation? So the linearity is a linear first order. Linear first order. It's linear. So I'll explain why it's linear. So this equation is linear because the unknown function dy dx, or the dependent variable, is of degree 1. So as long as the dependent variable is linear in terms of its derivatives, we say that this equation is linear. One may be wondering that we have an exponential function here, but note that the exponential function is not in terms of the dependent variable. The exponential function is in terms of the independent variable, and then the equation clearly is not dependent on this exponential function, and therefore we say that this differential equation is linear. Good. So we finished talking about this. Let's move to another differential equation. I hope it's clear. So let's get another one and talk about it. Good. The second equation we can get is y prime prime. y prime prime equals to sine y, it's sine x times y plus e exponent x. So we have this equation. We want to see its order, degree, and linearity. So this is a second order. A second order because it is the highest derivative is 2. The highest derivative is 2. It means the differential equation is or the equation is differentiated second time or 2 times. That is why we have y prime prime. Note that y prime prime can also be written as d squared y dx squared, meaning that y has been differentiated twice in terms with respect to x. Y has been differentiated twice with respect to x. So that is what we mean by y prime prime. So it is second order. The highest derivative there is second order. And then we talk about the degree. So it's of degree 1 or first degree, just as we said, because the degree or the power of the highest order, the degree of the highest order is 1, and therefore we say that it's of degree 1. Now linearity. Is it linear or non-linear? It is linear. It is linear because the unknown function, the power of the unknown function is 1. The power of the unknown function is 1. So you see that the unknown function y here. This one is not a power. You know that it is the order. It's not degree. So the degree of the unknown function is 1. I mean the dependent variable. So if the power of the independent variable here, if the power of the unknown function is 1, we say that the equation is order 1, or the highest degree is 1. So we say that. And this, are we saying it's linear? Yes, that's what I said, linear, because the dependent variable or the unknown function is linear in terms of its derivative, and therefore we say that it's linear. Good. So this is a linear second order. So we say that this equation is linear second order, and it's of degree 1. So linear second order of degree 1. So I want to clean this, and then we move to the third equation we'll talk about today. So the third equation is going to be, so d squared y, this is d squared y, the x squared is given as x sine y plus e exponent x. Then this. Then we have this. This is a second order because it is differentiated twice. So second order. And then of degree, it's of degree 1. The highest, the exponent of the highest derivative, or the power or the degree of the highest derivative is unity, and therefore we say that it's 1. It's just 1. And then linearity. We want to see if this equation is linear. Although we see that the degree of the highest derivative or the unknown function here is 1, we cannot conclude that it is linear, since we have a nonlinear function in sine. You know, sine is a nonlinear function, and it is in terms of the unknown function or the unknown variable y here. So we say that as long as the nonlinear function sine is in terms of y, which is the dependent variable, we say that this equation is not linear or non-linear. It's non-linear, you see, or not linear. So that is it for this one too. Let's move to last but not the least. We have this equation. I think we may have some 5 or 4. Have y prime prime. This is second order. Y prime prime squared plus xy is equal to root of y. So let's see the order, degree, and linearity. Now this is a second order. Because the highest derivative is 2. And the degree is also 2, or second degree, because the highest derivative there is of power 2, and therefore we say that the degree is 2. Is it linear? This is actually non-linear, it's clear. Although this one shows that it is non-linear, we also have in this not linear, because y is of power not equal to 1. So it's power half, and this power half is not equal to 1. So anytime that you have the unknown function or the dependent variable, any of them, or the unknown function or the dependent variables whose power or degree is not equal to 1, if it is less than or greater than 1, we say that it is nonlinear. So you see that this one is of power half, which is not equal to 1, so it's nonlinear. And then the second order, the highest derivative is also power 2, so we say that it is not linear or non-linear. So non-linear. And then let's move to the next equation. I think this is also obvious. So we have this equation. So we have d squared y over dx squared plus x over y equals to 0. So we are going to talk about the linearity. The order first, the degree, and then the linearity. We have second order because the highest derivative there is 2, second derivative. And therefore we say the order is second order. And then the degree. The power of the degree of the highest order is still 1, and therefore the degree is of degree 1. Is it linear? No, it is not linear. Although the unknown function here is of power 1. We see that x, let me write this one, x over y is the same thing as writing x multiplied by y to the power minus 1. And you see, this is also the unknown variable or the unknown function, a variable in terms of the unknown function y. So as long as we have the unknown function in terms of y, see that y is also not of power 1, and therefore you can say that one of the unknown variables here is of degree not equal to 1. So we conclude that the whole of this differential equation is nonlinear. So nonlinear. It's nonlinear. Good. Now let's pick. This is the fourth one. Sorry, this is the fourth one. I think we are talking about fourth one. I think this is the fifth or fourth one. I might have mixed up the numbers, but what we are interested in is we've seen the equation. So let's move on to the next equation. Quick. So I think this should be the last equation we will discuss for today's lesson. E to the power x, d cube y, the x cube. Let me get rid of this for the other equation, plus, let's change marker, y d cube x plus d squared x d squared y, sorry, the x squared. I think this is good for the powers. Good. And this is e exponent x. This is dy dx plus we have all this one squared is equal to 0. So this shall be our last example for today. We have on the board here e exponent x d cube y dx cube plus d squared y dx squared all squared is 0. So the order is third order or order 3 because the highest derivative there is clearly 3. And then degree, it is of degree 1. And then somebody may ask, why is this equation of degree 1 whilst we have a power of 2 here? We said that the degree is the degree is the exponent or the power of the highest derivative or the highest order. Clearly this is the highest order and its degree or its power is 1, and therefore we say that it is of degree 1. Linearity. Is this equation linear? No. One of the unknown function is exponent. It's exponential or it's of power 2, and therefore this is non-linear. Thank you very much for following today's episode. We are going to move on to finding solutions to ordinary differential equations in our subsequent videos. Please do well to subscribe for us and share. Make sure that your colleagues are following. And then I have already told you that this channel is dedicated to solving math questions, giving you very intuitive educative videos or giving you very intuitive lessons here. I told you that for the tertiary level we have started with ordinary differential equation. We're going to talk about numerical analysis. We are going to talk about coding theory and cryptography later on. That is, all of them will do the introduction first. So that is basically what we are going to start with. We'll move on to functional analysis, and then I also talked about partial differential equations after the ordinary differential equations shall follow. So do well to subscribe and then share for us, like the video. Your comments are all welcome.